During your student organized learning environment or SOL today, students will be able to choose 2 Flipgrids to create that demonstrate your understanding of chemical equations. A chemical equation looks like this. It's a representation of what happens when chemicals combine and have a reaction. In this case, you have hydrogen and oxygen, which combine to create water or H2O. On each side of the equation, you need to have the same number of atoms. So there are 4 hydrogen atoms here and 4 hydrogen atoms here. 2 oxygen atoms on this side of the equation and 2 oxygen atoms on this side of the equation. So it's always important to have the same number of atoms on both sides of your equation. We're going to look at photosynthesis as a chemical reaction and its equation. Photosynthesis is the process by which plants make their own food using carbon dioxide, water, and sunlight. So you have sunlight hitting plants. That's our energy, the sunlight. And you have reactants, which are what goes into a chemical equation. In this case, it's water and carbon dioxide and sunlight. Water is represented at the bottom by H2O, and carbon dioxide is represented by CO2. Again, that becomes, with this arrow representing what it becomes, our products, which is what comes out of our chemical equation. And in this case, it's glucose and oxygen. Glucose is a large, complicated molecule represented by C6H12O6. C6 means it has 6 carbon atoms, H12, 12 hydrogen atoms, and O6, 6 oxygen atoms in that molecule. Our other product is oxygen, or O2. Luckily for us, these are both important molecules that we need to survive. On the other hand, we have cellular respiration, which is a complementary process to photosynthesis. It's the process by which organisms use oxygen to break down food molecules to get chemical energy for cell function. So we have somebody living their best life doing some meditation. Even though she's meditating, she's still using energy, and that is represented by this chemical equation. Every chemical equation has reactants, or what goes into the equation. In this case, it's glucose and oxygen. Remember, glucose is this big molecule, and oxygen is this molecule here. Glucose is represented by the formula C6H12O6, and oxygen is represented by O2. It becomes, which is represented in our arrow here, our products, which is what comes out of a chemical reaction. In this case, it's water, carbon dioxide, and energy, or ATP. Water is represented by H2O with 1 oxygen and 2 hydrogen, and CO2 is represented by CO2 with 1 carbon and 2 oxygen. Now, it's important to remember that plants also do cellular respiration because they are living things, and when they grow, they're doing cellular respiration. So it's not just animals that do cellular respiration, but all organisms also do cellular respiration. It's a cycle. So the reactants, glucose plus oxygen, becomes H2O and CO2. And what you'll notice is that H2O and CO2 are the reactants over here. Then the products of photosynthesis, C6H12O6, or glucose, and O2, or oxygen, are the reactants here. So it's a cycle. The reactants in cellular respiration come from the products of photosynthesis, and the products of cellular respiration are the reactants in photosynthesis. So it's a cycle. But this is not equal. There are more atoms on the left side of the equation than on the right side, so it is not equal. For example, there are 6 carbon atoms on this side, and on this side there's only 1 carbon atom. So how do we balance the equation or make this side equal to this side? Well, we have to look at our reactants. Remember that glucose is a big molecule, C6H12O6, and has to be equal to our products. So instead of just 1 carbon dioxide, we need 6 carbon dioxide. So now our carbon is equal on this side to this side because there are the same number of carbon molecules. In the same way, right now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen molecules on this side. So we need 6 water molecules in order to have 12 hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to have enough hydrogen on this side of our equation so it balances. Now, if we look at it, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 oxygen atoms on this side, but there are only 1, 2, 3, 4, 5, 6 oxygen atoms on this side of our equation. So we need 6 oxygen molecules, which will have 12 oxygen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 more oxygen on this side. So now we have the same number of atoms on this side of the equation as we do on this side of the equation. Our equation is balanced. We already know that the number behind the element represents the number of atoms in the molecule. So C6 means that there are 6 carbon in glucose, H12 means that there are 12 hydrogen in glucose, and O6 means there are 6 oxygen in glucose. The number in front is going to say how many we need for our balanced equation, how many molecules we need. So in this case, we need 6 carbon dioxide. So we put that 6 in front of carbon dioxide. So there are 1, 2, 3, 4, 5, 6. So that's how we know how many carbon dioxide molecules are needed. In the same way, we put a 6 in front of H2O. So 6 water molecules are needed. 1, 2, 3, 4, 5, 6. And then in order to balance it again, we need more oxygen on this side. So we have 6 more oxygen. 1, 2, 3, 4, 5, 6 more oxygen molecules. The same thing is true for photosynthesis. You'll notice that these reactants are the same as the products here. So the reactants and products are the same. But in order to have it balanced, we need to have the same number of atoms in our products as we do in our reactants. So that's true for photosynthesis and cellular respiration. Just like in cellular respiration, we put that number in front of our molecules to represent how many molecules we need for that balanced equation. So we need 6 water molecules, 1, 2, 3, 4, 5, 6. 6 carbon dioxide molecules, 1, 2, 3, 4, 5, 6. And this is all because our glucose molecule is so big and complicated because it has 6 carbon, 12 hydrogen, and 6 oxygen. But there's not enough oxygen in this molecule for our chemical equation, so we still need 6 oxygen. 1, 2, 3, 4, 5, 6. Remember that the number in front of the molecule represents how many molecules are in the equation, and the number behind represents the number of atoms in the molecule. So the way you figure out how many oxygen are in 6O2 is you simply multiply the number in front by the number behind, so 6 times 2 is 12, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 oxygen in this example. The same is true over here, so there are 6 carbon dioxide. 1, 2, 3, 4, 5, 6. You take 6 times the number behind here. If there is no number, that means there's simply 1 carbon, so 6 times 1 is 6. 1, 2, 3, 4, 5, 6. And then for our oxygen, we have 6 times 2, because you take the number in front of times the number behind. So there are 12 oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 oxygen in 6 CO2. For the Flipgrid choice board today, you're going to choose 2 of the 4 options. 1, you can explain the connection between sandwiches and molecules in this simulation. A hint is that we have reactants and products and leftovers, which is what is left over from a chemical reaction. Here it would be very similar, where our reactants and create new products and leftovers. Your second option is to create and explain a new metaphor for chemical reactions like banana splits, banana ice cream, and chocolate sauce molecules combined to make a banana split molecule. So what would be a new one, not banana splits, but another metaphor to explain to someone how chemical equations work? Your third option is explain the similarities and differences between photosynthesis and cellular respiration, which we went over today. How are they connected and what's going on with that? And your final option is explain to a 10-year-old how to play the game at the end of this simulation. So if you look at this simulation, there's a game here, and how do you play this game? Remember to use the vocabulary down here: products, reactants, chemical equations, and chemical reactions.